Hey everyone, and welcome to today's explainer. Today, we're totally bridging the gap between abstract programming concepts and actual practical web page manipulation. We're going to build a seriously powerful JavaScript loop right before your eyes. If you've ever felt like coding tutorials just stay way too stuck in the theory, well, you're absolutely in the right place because we're getting totally hands-on today. Let's jump in. So imagine having to manually change HTML elements on a page, one by one by one. If you have 5 links, it's annoying. But if you have 500, that's a literal nightmare. Today, we're going to solve that exact pain point. We're exploring how a loop can automatically cycle through and modify web page elements in bulk. It is a total game changer that will save you countless hours of tedious manual coding. Here's our roadmap for this explainer. We'll look at the power of loops, grab elements the modern way, break down a loop's anatomy, put it to work, and finally, explore the endless possibilities this unlocks. All right, section 1, the power of loops. Let's just dive straight in and establish our starting HTML environment. Our starting point is actually remarkably simple. We've got an HTML file containing exactly 6 anchor tags, which are of course just your standard web links. But notice how they're numbered here, explicitly from 0 to 5. We're setting the stage and prepping for some serious automation. Now you might be wondering, why on earth are we starting at 0 instead of 1? Well, we start at 0 because JavaScript is a zero-based language. This means that when we're working with arrays or setting up our loop indexes, the computer doesn't begin counting at 1, it actually begins at 0. By setting our HTML links to match, link 0, link 1, link 2, we make it incredibly efficient to align our document structure directly with our code's underlying logic. It just makes everything click together. Section 2, grabbing elements the modern way. To manipulate these specific links, we obviously need to grab them from the document first, and we are upgrading the traditional approach to do exactly that. So there's a stark contrast between legacy beginner code and modern professional code. If you watch older tutorials like the really excellent NetNinja tutorial that inspired part of this explainer, you'll often see var and get elements by tag name being used. And hey, that's great for beginner simplicity, but the JavaScript ecosystem has evolved. Modern professional best practices dictate a much cleaner, more robust approach to avoid bugs and keep everything running strictly. So here is our modern upgrade. By using const, we declare a variable that definitely won't accidentally be reassigned later down the line. And by using query selector all looking for that A tag, we confidently store every single anchor tag on the page into a tidy little array. This array, which we named links, allows us to reference each link by its specific numeric position. Basically, we've gathered all our targets into one neat modern package. Moving right along to section 3, anatomy of a for loop. With our elements securely grabbed and waiting in that array, it's time to actually build the engine. A standard JavaScript for loop requires these 3 distinct components, running just like clockwork. Step 1 is the initializer. Notice we're using the modern keyword let here to declare I equals 0. Why? Because I is absolutely going to change, and let safely restricts this variable to just this specific loop. Step 2 is the condition. The loop's going to keep running as long as I is less than the total length of our links array. And step 3 is the increment. I++ simply means we increase I by exactly 1 after every single cycle. Start at 0, check the limit, run the code, add 1. Simple, right? Section 4, putting the loop to work. Let's jump into the action phase and look at what dynamically happens inside that code block during each iteration. As highlighted really brilliantly in the NetNinja tutorial, the magic happens because we can use that number to grab a specific link in this array. That I variable, it isn't just a counter, it is literally a key. Because I goes from 0 to 1 to 2, it perfectly matches those 0-based positions of our links in the array we created a minute ago. And here is the exact line of code that does the heavy lifting inside the loop. We write links, open a bracket, and pass in I. This targets one specific link for this exact cycle. Then we dynamically assign a class name to it. How? Well, by taking the literal text string link dash and concatenating it, joining it together with the current numeric value of I. This visual brilliantly illustrates the engine in motion. Look at the first iteration. Our I value is 0, so the computer assigns the class link0. The loop increments. On the second iteration, I is now 1, so the element gets the class link1. It literally zips through the DOM, dynamically generating unique sequential classes for every single selected element on the page in a matter of milliseconds. Section 5.
endless possibilities with loops. Let's step back and see how this fits into the bigger picture. Once we refresh the browser, the loop has successfully processed every single anchor tag without us having to write tedious manual HTML updates.
So the absolutely crucial point here is this. Sure, we use this loop to assign sequential class names today, but guys, that is just the tip of the iceberg. You can use this exact same modernized logic, leaning on your const, let, and query selector, to animate a wave across elements, change text styles based on user inputs, or even bulk update database content across an entire dashboard. It gives you maximum leverage, a few lines of code yielding massive results across the entire document.
Now that you've totally mastered the modern setup, loop iteration, and dynamic DOM manipulation, the manual limits are completely off. You have the engine built. So the question I want to leave you with today is this: what complex web page update are you going to automate next? Thanks so much for joining me for this explainer, and happy coding!